All right, in this example I'm going to look at several different types of problems you can do with basic right triangle trigonometry. I'm going to be looking at your Sohcahtoa rules. As a reminder, the sine of an angle is equal to the length of the side opposite over the hypotenuse. Again, we're assuming you have a right triangle here. The cosine of an angle is equal to the adjacent side over the hypotenuse. The tangent of an angle is equal to the opposite side over the adjacent side. And so, for example, I could ask you to find something like the sine of angle A. And keep in mind, the sine, cosine, or tangent, just in general, is a ratio. Okay, it's a fraction, it's a comparison of sides in a certain right triangle, and that's it. So I'm not going to be solving it for anything in this particular problem. Sine is just the opposite side over the hypotenuse. So I go to angle A, the opposite side is 3, the hypotenuse is 5, sine of angle A is 3/5. All right. If I wanted to find the tangent of angle C, tangent is the opposite side over the adjacent side. Whoops. Actually, I can't find the tangent of angle C because it's the right angle. It needs to be the two acute angles. Let me try the tangent of B. The opposite side, 4 is the side that's opposite angle B. The adjacent side is 3, and we would say the angle is 4/3. Now, you look at that and you say, well, who cares? You just made some fractions involving sides of a right triangle. And that's exactly right. There's several things that you can do here. First of all, you can use these values to find angle measures. So if you ever wondered, for example, what the measure of the smallest angle in a 3, 4, 5 right triangle is, you can actually use your calculator to do this. So I'm going to go back to this original equation. If I want to find the angle whose sine is 3/5, in the old days I'd go look at a chart, and you'd go look for 0.6 on a chart, and you'd match it up with the angle measure on a sine chart. Well, we don't use sine charts anymore for the most part. So instead, you're going to do this on your calculator, all right? Your calculator doesn't solve equations. So, you don't want to type sine of A equals 3/5 in. What you want to use is the inverse function, the inverse sine function on your calculator. Sometimes it's called the arc sine. And what an inverse function does is it lets you switch the input and the output. Normally you put in an angle measure and you get out a fraction or a decimal. We want to put in the fraction or decimal and we want to get out the angle measure. So how this is going to work, I'm going to use the inverse sine. By the way, that symbol is used for an inverse, even though it kind of looks like a -1 power and it looks like it might be a reciprocal. It's not a reciprocal, just an unfortunate use of terminology. And I'm going to do the inverse sine of 3/5. And my calculator should give me back something that looks like an angle measure, probably with a decimal. On most calculators, you're going to have to hit a second button. The inverse sine button is the second key that's above the sine button. So I'm going to hit second, inverse sine. I'm going to type in 3/5, or you can type in the decimal 0.6 if you prefer. And you're going to get approximately, again, this is infinite decimal, 36.869, and then the decimal continues. So about a 36-degree angle. Going to make this angle up here about a 54-degree angle. Turns out 3, 4, 5 right triangles do not have whole number integer angle measures. But that's the basic idea. So inverse sine, cosine, or tangent, or also called the arc sine, arc cosine, arc tangent, is used to find angle measures. Now, more importantly, most of the time you're going to want to find side lengths of triangles using sine, cosine, or tangent. So let me show you how that's done. Pretty classic example. If you have a person standing on a cliff, okay, or let's say that there's a measurement being made on a cliff, and you have maybe a boat or something like that out on the water. You have what's referred to as the angle of depression. Okay, there's also something called an angle of elevation. And the basic idea here is, let's say that this is a 100-foot cliff, and let's say that you want to figure out how far away the boat is from the cliff, okay? Sometimes what's called an angle of depression is measured. In this case, let's say that the angle of depression is 20 degrees, okay? The mistake that a lot of people make is they say, okay, I'm going to do an angle down here to the boat. You know, here's my angle, that's my angle of depression. That is not the angle of depression. If you think about what's happening, when somebody's standing on that cliff looking out at the boat, again, maybe we have a little guy standing here, that kind of thing. When that guy looks out at the water, that guy is looking straight out to the water. Okay? This person's sight line is going like that. When you depress your head to look at the boat, the angle that your head is tilting through is actually this top angle right there. That's the angle of depression. All right? If you remember earlier in the year, this is a horizontal, the water is a horizontal. I have alternate interior angles. That's also a 20-degree angle down there. Okay? This is the angle of elevation, how far somebody down at the boat would tilt his or her head up to see the person on the cliff. All right? The angle of depression is equal to the angle of elevation. You can use either one in a given problem, but you have to know where it is. Also, there's a 90-degree angle here. If you wanted to subtract, that's a 70-degree angle there. All right? Now, let's look at what we have. What I have here is a right triangle. Be careful. Sometimes the problem will say, how far is the person from the boat? And that would be this hypotenuse length here. I'm going to find out how far the boat is from the cliff. And so I've got a 100, I have an x, and I'm going to use the 20-degree angle down here, although you could use the 70 up here and get the same answer with a different rule. Okay? It's very easy to work with sine, cosine, and tangent. You always find the sine, cosine, or tangent of one of the acute angles. So in this case, it's going to be 20 degrees that I'm using. This is the opposite side. This is the adjacent side. We're going to be working with the tangent rule here. So it's the sine, cosine, or tangent of your angle measure equals your fraction. So the opposite side is 100. The adjacent side is x. Okay? You can go ahead and run the tangent of 20 on your calculator. Your calculator is basically going to tell you what fraction this is supposed to work out to be, and then later you're going to solve the equation. Okay? I prefer to put this over 1 and cross multiply. The other thing that you could do here is, if you wanted to get this out of fractional form, you can multiply both sides by x. X is then being multiplied by the tangent of 20, and you could divide both sides by the tangent of 20, and that would also give you your value of x there. But I'm going to put it over 1, and I'm going to cross multiply. I think that's pretty easy for everybody to handle. So I'm going to get x times the tangent of 20 is equal to 100 when I cross multiply going the other way. Tangent of 20 is a decimal. You can find that decimal right now, or if you want to isolate your x variable, you can divide by the tangent of 20. If you're comfortable doing this, I actually would suggest you do it this way, because what you can do now is, this cancels on this side. I get x is equal to 100 divided by the tangent of 20, and I can just divide this in here on my calculator, and I have an answer. And I don't have to worry about rounding error if I do it that way. So x is going to be approximately 274.75 if I round to the nearest hundredth. And the original measurement was in feet, so there that is. You should be able to look back and see if your answer makes any sense. Notice that the 20-degree angle, the smallest angle, is across from the 100. The 70-degree angle is larger, so this side should be larger, and you can see that that 274 feet does seem like something that might be more likely to go with the 70-degree angle. So that's the idea. Hopefully that's been a helpful couple of examples of using trigonometry to find missing measures. I'm going to look at another trig example. In this problem, I have a situation where I have a cliff, and I'm going to make it a 1,000-meter high cliff. And a person is sighting two different boats off the edge of that cliff. So I've got some water here, and two different boats. One boat's a little bit closer. One boat is a little bit farther away. And I have the measure of the angle of depression that goes to both of those boats. Okay? The angle of depression will be the smaller angle going to the farther away boat. The angle will be a little bit bigger for the boat that's a little bit closer. So we're going to say that the angle of depression from the top of the cliff to the first boat is 32 degrees. Or, I'm sorry, 47 degrees. So we have a 47-degree angle of depression. And I'm going to have a 32-degree angle of depression moving to the other boat. So I've got this line here going out like this, and that's a 32-degree angle of depression. Now, just a reminder, when you measure an angle of depression, remember that you view at a horizontal, straight off the cliff. That's your regular viewing angle. So when somebody looks off this cliff here, and and they measure those angles, they're measured at a horizontal. So basically we're saying that the 47-degree angle is that angle right there. We're saying that the 32-degree angle is this smaller angle right there. Okay? An easier way to see this, I've got alternate interior angles here. It's basically saying that there's a 47-degree angle down there, and it's basically saying that you use your alternate interior angles there, there's a 32-degree angle here. So the angle of elevation from this boat to the top of the cliff is 47 degrees. Angle of elevation from that boat to the top of the cliff is 32 degrees. All right? Let's say that I wanted to find the distance between these two boats. Okay, how far apart are my boats? I can maybe call that x. Well, when you first look at this, this looks like a really complicated problem because first of all, it kind of looks like there's a triangle here, but it's not a right triangle. We haven't dealt with triangles that aren't right triangles. And so the question is, well, you know, what do I do here? Actually, this problem really isn't as tough as it looks. And it's all about noticing that there are really two right triangles in this diagram. There's one right triangle here, and there's a bigger right triangle here. And if you can use those two facts, it's going to make this problem much, much easier. So let's try it. I'm going to draw each of those two triangles separately. Okay, I've got the smaller triangle here. It has a height of 1,000 meters. I'd like to figure out how far this boat is from the cliff. So I'm going to call that, I won't call it x because I already used x. I'll call that A. And this is a 47-degree angle. Okay, every trig problem you're going to have an angle involved and two sides in a right triangle, one of which will be a variable. There we go. We'll take out the answer for the time being. All right, I have a second right triangle. Okay, for that second right triangle, it's longer and thinner. It's got a 32-degree angle right here. The height is still 1,000 for that bigger, longer triangle. I'm going to call this length here B. All right? If I can figure out how far this boat is from the cliff, and I can figure out how far that boat is from the cliff, I'm going to be able to find out how far apart the two boats are. And just subtract to the end. So if you notice here, I've got a right triangle with angle measures, opposite, adjacent. That's a tangent of 47 degrees, equals opposite over adjacent. It's 1,000 over A. Okay, over here, same thing, opposite over adjacent. That's tangent of 32 degrees equals 1,000 over B. I'm going to simplify things a little bit here. If the question says to round to the nearest tenth, let's say, I'm going to use several decimal places more than that, but I think this will simplify the problem a little bit. Tangent of 47 is about 1.0723. We'll say 4, we'll round here. And that's equal to 1,000 over A. Okay, again, approximate answer here. You may want to leave all this in your calculator till the end and get a little bit more precise answer. Tangent of 32, meanwhile, is approximately 0.6249, and that's equal to 1,000 over B. And we should be able to solve both of these equations now. You can multiply both sides by A and then divide. You can put it over 1 and cross multiply. I've always found that to be a little bit easier for people. So I get A times 1.0724 is equal to 1,000. I get 6.249B is equal to 1,000 over here. And so I'm going to go ahead and divide that. The 1.0724. By the way, that is the tangent of 47. So you may want to go back in your calculator and actually type in the tangent of 47. And basically you're going to be dividing 1,000 by that value. Okay, so really 1,000 divided by the tangent of 47. And that's going to be approximately 932.52 meters. And meanwhile over here, that's the tangent of 32. So I'm going to be dividing both sides by the tangent of 32. So 1,000 divided by the tangent of 32 tells me that B is approximately 1,600.33 meters. Okay, so we put this all together. This boat is 1,600.33 meters away from shore. The other boat is 932.52 meters away from shore. If I subtract those two, it's going to tell me how far apart my two boats are. So subtract my 932 actually, I'm leaving the values in my calculator here. And basically, I find out that the distance between the two boats is approximately 667.82 meters, if I round. So again, be on the lookout for cases where you have two right triangles. If you have two right triangles, you might be able to use two Pythagorean theorems, you might be able to use two trig equations, lots of different possibilities to come up with the right answers. An idea that's really important both in Algebra 2 courses, in pre-cal courses, even into calculus courses, and ties in a little bit with your geometry courses as well, is the ability to find sine, cosine, and tangent values of basic angles, specifically 30-degree angles, 45-degree angles, and 60-degree angles by hand. So I'm going to show you how you can do that relatively easily. For example, let's say I want to find the sine of 30 degrees. Hopefully you look at that and you say, hey, 30 degrees, where have I seen that before? Oh yeah, I've seen it in 30, 60, 90 triangles. You can make any 30, 60, 90 triangle and it'll simplify down to the correct answer. Now my suggestion here is to make the most simple one that you can. Some books will have you do this with an x and a 2x and an x radical 3. I think you can make it even simpler to reduce your overall fraction than that. I make my short side 1. Means my hypotenuse is going to be 2, means that my long leg is going to be radical 3. And check out how easy this is. If you think about your Sohcahtoa rules, sine is equal to the opposite side over the hypotenuse. So you go to your 30-degree angle, which of course is up here in this case. The opposite side is 1, so fill that into my fraction. The hypotenuse is 2, and you find out that the sine of 30 is 1/2. And if you check your calculator, you're going to find out that wow, you're magical. You can actually come up with the same answers as your calculator. Amazing how that works, huh? Second of all, let's say that I wanted to find the cosine of 30 degrees. Well, cosine is the adjacent side over the hypotenuse. So you come back up here, the adjacent side is radical 3, the hypotenuse is 2, and that's the cosine of 30 degrees. Again, if you check your calculator, you'll find that the decimal is the same thing as the decimal you get here if you have your calculator crunch those numbers. I can also do this with 45, 45, 90 triangles. Now let me do one more here. Let me do a tangent of 30 degrees, just something to remind you of here. Tangent, of course, is the opposite side over the adjacent side. Opposite side here is 1. The adjacent side is radical 3. You may have to simplify some radicals, or in this case, rationalize some denominators. So 1 over radical 3 is sort of correct, but it's not written in the best form. You can multiply numerator and denominator by radical 3. Radical 3 times radical 3 is 3, and that's a little bit better answer. You can do the same thing with 45-degree angles. You can make a little 45, 45, 90 triangle. So for example, if I want to find the sine of 45 degrees, sine of 45 degrees, well, sine is the opposite side over the hypotenuse. So again, make yourself a little 45, 45, 90 triangle. I make the two legs each 1, and that means the hypotenuse is going to be radical 2. And again, the opposite side, you have two 45-degree angles here. You can pick either one you want. So I'll pick this one down here. Opposite side is 1, when the hypotenuse is radical 2. Again, you do have to rationalize the denominator. You end up with an answer of radical 2 over 2. Really, really, really central idea to some topics that you're going to discuss late in Algebra 2, and hugely central to things that you're going to do in your pre-cal.